So what people thought of, right? There are some other things are there. People are talking about ADK and all those kind of things. Okay, you have to be here with. But before that, people have talked about that why can't we do this kind of things? Suppose a particular key is there, right? It's a random key, right? And then this key is mapped to a large set of keys, right? So it is K1, K2, K3, K4. So it is Z0, Z1, Z2, Z3. Where the size of the key space or size of this Z space is much larger than this one. Right? So what we are trying to do that we try to find out the mapping functions from a particular random number. I will generate. Can I generate a large sequence of bit strings? Right?
So that will be done in a cipher is decryption and not encryption.
Encryption only. Encryption only.
Means this distribution we are performing as sender side.
Yeah.
That is performing as from sender side.
Sender side.
Otherwise, the big string to it transmit.
So this key is there. I generate this one. At the other end also, this key is known. So they will generate this particular thing and they can pull it out. Right? So only thing is that this key has to be known for both the sender and receiver. Right? So he will generate this particular kind of things and he will also generate these things. Right? Right? And then he can do this particular kind of things. Right? And then the plain text will be P0, P1 will be joined. Right? So in this case, what we are trying to do to reduce the overhead of the perfect security, this one-time band. That what we are trying to do, that we are trying to this from the given particular kind of things, a small key, I try to find out a bigger random-like key, and that is we call it the pseudo-random keys. And then we did this.
Sir, how long or for how much data value it will be feasible, sir? Means for distribution. Suppose we are having suppose nowadays we are using a key size of around 64 to 128. If we will be considering that amount of key size, then how long or how much big distribution is possible for that?
Yeah, so it depends upon this pseudo-random generator functions. Right?
Okay.
Now, if I use a pseudo-random generator functions, like say we talk about linear shift registers. Shift register. Say we have got a particular shift register is there, right? So that everyone knows this is K1, K2, K3, K4 without this shift register, right? And at each point of time, at each clock pulse, three things work simultaneously. So one thing is that the bit that is there at this particular position is taken out. Right? Second thing is that a linear combination of these four bits is replaced to these particular positions, right? And then all the symbols are shifted by one positions, right? So these three things are done simultaneously, right? So this is what the linear feedback register is there, right? So all of you are aware of these things, right? So in that case, what happens, right? To your questions, that in that case, we will find out the key of a period of size if it is 2 to the power 4 minus 1.
Okay.
64 characters, I can find out a pseudo bit of 15 cycles. After 15, it is again pseudo. Right? So you can try it out. Right? You can take the example itself, you can find out. So it is 64, right? So we can find out a random number generators with 2 to the power 64 minus 1.
1.
So it will repeat only after 2 to the power 64 minus 1, and it's a huge number. Right? So this is what the concept of the string cipher that we are talking about. But then what is happening? So here, each bits that we are generating are nothing but what? The linear combination of the existing bits.
Yes.
Right? So if I can find out, if I have got a particular model, I can get 4 plain text and ciphertext pair. Right? Okay. So in that case, what I can do? I can find out for each particular plain text, right? I can find out the linear combination values, and then I can find these linear functions, right? Easily. With only 4 plain text ciphertext pairs, right? So if I get a plain text and ciphertext, I can find out the key. If I get say P and K, right? So C is nothing but P XOR K, right? Okay? So this is what we are talking about. The plain text only attack, right? I got plain text, also the corresponding ciphertext, right? So from that I can get back the K. K is equal to what? P dot C, right? So if it is substitute, is it okay? So I got the P, right? And I am applying this K is not this is Z, right? So Z is the stereo bit that they have generated, right? So if I know C and also P, the corresponding P for a group of elements, right? So I can find out the K value, right? And then from that particular K value, I can easily find out these linear functions, right? If the key size is say 4, right? With 4 such bits, 8 number of bits, right? I can easily find out these mapping functions, and then I can break the cipher. Right? Okay? So although this particular linear register kind of this LFSR kind of is very useful, it has given very random kind of things, right? With large period, right? But then because of these linear functions, right? It is susceptible to plain text only attack, right? If I get a ciphertext, if I get a plain text, right? So I can find out the key, and from the key below, I can find out this linear functions. Is it possible? So you can always do this kind of thing. If you take for example, you can do it. Right? You can have a value of K, right? Because this K4 is nothing but what? Something like this. K1 XOR, so say I am going to go K5, there K1 XOR, say K2 XOR, K3 XOR, K4, right? And say something like C0, K1, C2, C1, K2, C2, K3, C3, K4. So C0, C1, C2, C3 are nothing but either 0 or 1. So if it is 0, right, so it means the K1 bit will be used to generate the next bit, right? If it is 1, it will be used to generate the next bit, right? Okay? So if I can find out 4 such bits, right, key bits, right, so I can easily find out what? This particular function, what is the value of C0, C1, C2, C2? Not 4, 8 number of bits if I can find out. Right? So for one particular kind of bits, it will be like this. Because I know K5, because I already find out from the plain text ciphertext, I can find out K5, right? Then again I can find out K6, right? Then again I find out K7, I can find out K8. whatever 4 functions are there, 4 unknowns are there, so I can find out C1, C2, C3, C4. So the problem with this particular kind of thing is that because it's a linear function. So is it possible to replace these linear functions with non-linearity? Because this is in a hardware kind of thing, it's very easy to implement. Only a shift register is required, nothing else is required. Now what are required? Whether this particular kind of things can be replaced by a non-linear functions, right? Or it might happen that when I apply this particular kind of things, right, I can use a number of LFSR, right, and those LFSR bits, right, what will do? Linear combination of the LFSR bit I will map to. So this is combination of 1, 2, 3, 4, and from there I will map it to the output bit. Okay? In 4 is to 1. 4 is to what? Substitution box. Right? So this is the output of the linear combination of bits of the first LFSR. This is the linear combination of the bits in the second one and this one, and then that one will be mapped to by the S box and it will go to this one. And the property of the S box should be like that. That this is purely non-linear kind of things. Right? So if I can do that, so this particular kind of things will be useful. So people are talking about how to improve this non-linearity of this particular kind of things without having very large overhead. Right? So this is very simple, but it is susceptible to this due to linearity. It is susceptible to these attacks. Right? The plain text only attack. Now, can I replace this particular things with a non-linear function? People are working on this particular things. People are working about whether you can go for the elliptic curve kind of things, whether you can go for how to design a S box, which is for the large linearity. So many boxes are going on. So let us stop it over here.
Yes, sir.